baseball game let out and nobody knew where all the buses were. So anyway, we've done it in a way that we can deploy it to other cities. We do have it running, we may have turned off Syracuse, I think it is running in New York City, but we never advertise in New York City, so we have almost no users in New York City. But we have accumulated up to this point over 195,000 trip contributions. And by the way, if you go to our website, that number's not going to look right on our page because we're switching our servers over, so don't be fooled. Anyway, this trip count, the vast majority are origin destination. I'm going to tell you about another method of people contributing, but most of this is OD pairs, because we ask where you're getting on, we know where you're getting on because you're at the stop, and we ask you to tell us where you're getting off. So we get the OD pair, and then we trace you, and then we auto stop when you get close to your end. So the reason why we ask for destination is so we can auto stop, number one, for privacy reasons. Number two, we do it because otherwise your battery would just keep running. Because detecting that you actually got off the bus is hard. Did you get off the bus and walk into Starbucks and get a coffee, or is your bus stalled at that light because of traffic? Right, so that explicit, I'm getting off the bus is really important, so that's what we ask for. And we picked up a few awards along the way for this work. So we started all of this with a pilot. We didn't even know if it was going to work. So before we invested all this effort to recruit a lot of people and kind of so people with disabilities, there's a limited set, and the more of them you use, you kind of are essentially using up your population. So we went out and got a bunch of people without disabilities from a very specific neighborhood in Pittsburgh, specifically because we wanted them to be interacting with each other. We wanted them to be seeing each other's data. So we recruited them from this one neighborhood and set them loose over the course of 3 weeks. And they were paid, so they traced a lot. We didn't tie payment to tracing, but they felt like they had to trace, so they traced a lot. That was great for us. We say an impression, you might hear me say this again, this is called an impression. It's kind of like a web ad. This is, again, computer science terminology. So in this scene, there's 1, 2, 3, 4, 5, 6 impressions that we're showing to you. Okay? So of all the impressions that were shown to people, about 16,000, we ended up with pretty good performance in terms of coverage just off of this small set of people. Now, this is misleading. This is not a measure of coverage over all trips in the transit agency. This is only the trips, this is only the bus stops at the times that our users open the app to look. So this isn't at like 4 a.m. when nobody's using the app. This is only when people were opening and using the app. But still, that's really good for only 28 users. So we were actually pretty excited about this. And on top of that, all of the HCI measures in terms of whether or not people liked it and wanted to use it were extremely high. In fact, we were actually having ceiling effects on some of these. The other subtle thing that came up is people were reporting problems. We included the ability for people to document something that they encountered. The seat is broken. You can attach a picture, write a note, attach a picture, and send it in. It's one direction. This goes in. And in general, people with disabilities do notify the transit agency of problems. They're dependent on transit. If there's a barrier, they tell. They tell the agency because it's directly affecting their lives. Most of you don't. How many of you ever contacted your transit agency? You can't raise your hand. Right? 0. Maybe 1 or 2. Okay? Very rare that people without disabilities or people not dependent on transit do this. And without prompting, we had a bunch of this happening with our users. So we said, great, this is wonderful. Let's deploy it. So we did this and then we deployed it. Now, I mentioned reporting this. And we settled on text and photo because we actually ran studies to figure out what's the right way, how do people want to report problems they encounter when they're out in transit. And we had a bus shelter in our lab. It wasn't real, partially real. Port Authority was going to give us a bus shelter, but we really need a crane truck, and we were going to have to cut it in half to get it through the door. So we just went out and built our own bus shelter and put it in the lab. We brought people with and without disabilities in, at various different kinds of disabilities, and had them document fake barriers that we created in the lab. And what we found, we tried text and audio, There's the two kind of ways of documenting the problem. Then no media, pictures, and video. So there's 2 by 3. And what everybody kind of settled in on was text and photo. And we also looked at the quality. We actually went and did analyses on how good were these documents. And text and photo turns out to be the right approach as well. The problem with video is people do this. Start recording. Stop recording. Which is basically a picture with a lot of extra crap. Right? So don't bother with video. Audio was interesting. We thought that audio was going to be preferred by a lot of people. It turns out that almost everybody, except for those with severe dexterity issues, wanted text. And we had a measure of what we call social comfort, and that seems to be where this comes from. Nobody wants to be identified at the bus stop as the person who's complaining. Right? Oh, he's the whiner. Right? But I can fire off the nastiest, scathing message to my transit agency right next to you, and you never know. Right? So text is really powerful because of that social comfort factor. You can say anything you want, nobody knows. So this is where we think that it comes from. As an aside, we were also interested in supporting people who are blind, allowing them to take pictures. So we had a student who actually came up with a system that allows a person who's blind to take a better picture from an iPhone. It all runs locally, just boom, done. We didn't put that into Tiramisu because it's a major battery hog, because it does a lot of computation. But if you're interested in that, that particular code is open source, and I can point you at it if you want. But the cool thing is like the blind participants, like, can I take a picture of my dog? I don't have a picture of my dog. Can I take a picture of my dog? You know, so this turns out to be pretty cool. People who are blind want to take pictures. It actually happens. Okay, so so after deployment, we said, well, how are people using this? So 2 poor students went through the first 1,000 reports and coded them and categorized them. And if you want to know more about this, I can talk to you offline about it. But the short story is that people do report. They were actually using it, quite higher than we expected. There were a lot of these point of pain ones. This is actually something we were hoping to get. The idea is that there are a lot of problems you encounter when you're riding transit where you experience something that you don't like, and you're like, I gotta complain about that. Or you don't want to remember all the details, so you just kind of give up and you walk away from it. And that problem never gets captured. And so what you'd really like to do is capture that problem at the point of pain while they're mobile, so that you actually know about it. You can actually do something about it. Because otherwise it just disappears and nobody knows. And we got a lot of point of pain. So people were willing to do this while mobile. We had multiple incidents of people who don't have disabilities witnessing an accessibility violation and reporting it. And if you work in the disability community, this is awesome. This is a social inclusion thing. There's various cultural issues here going on. And that's evidence that you're seeing social integration between people with disabilities and people without disabilities. And so this is kind of a big deal. And we're really interested in how this evolves in some of our more current studies. I can come back to that later if you're curious. But in general, there was clear evidence that people want to communicate with their transit agency. They actually want to do this. So what we did with all of these reports, we did this for a long time, much after, even beyond this, where anything that was transit agency related, we triaged those out and we organized them and we mailed them off to the local transit agency and said, here you go. Maybe they'll do something with them. So, months later, I finally am in a meeting with the head of their customer service group, and I say, are you using these? Are these helpful? And he says, no. I can't do anything with them. There's no provenance on the data. It's not being collected by us. The union rules prevent you from using the data. Okay? So at that point we said, crap. Right? First off, I didn't tell the undergrads until after they graduated. Secondly, this causes problems, right? So this means that over the long run, all this great, kind of investment that people want to make into their system is basically lost and useless. And my recommendation, if you are working for a transit agency down the road, make your mobile website really easy to use for these kinds of things, number one. And number two, don't require all these special fields that people can't get. The badge number of a driver, Good luck getting that, right? Now, interesting. How many of you have ridden the Silver Line in Boston? Have you noticed something about their message boards with badge numbers? They post the badge number on the board, on the cycle of them, at least they used to, maybe they don't anymore, but on the cycle, as it rotates through all the different messages, the badge number shows up once in a while. It does not show up every cycle, which is weird. It's the only piece of data that doesn't show up every cycle, but it shows up every few cycles. Right? So that's another, if you're going to require badge numbers, think about how you surface it to your users. Anyway, okay. So we shifted away from this, and we moved into a completely different structure for reporting. I'll describe that when I get later into the talk. So anyway, we've been running since 2011. We have a lot of data. We can do all sorts of studies. We've been doing all sorts of studies and doing all sorts of data analysis, including A/B design. A/B design, I'm assuming, how many of you know what A/B design? I'm assuming very few. Okay, yeah, no. So you may not realize this, but Google tested out 26 different colors of blue to see which blue led you to click on those things the most. There is a blue, okay? If you go to Amazon and you notice that the format and layout of this product page is shifted, that's Amazon doing a test on you to see which one leads to more likely that you're going to buy something. Okay, so the way an A/B design works is you take this set of the population, you throw them into this condition, this set of the population, you throw them into this condition. It's completely random. It is actually very good from an experimental perspective. And so we did an A/B design with some motivation. We've also done some more detailed analyses on specific topics, and I'm going to cover a few of these. So the one that transportation people always ask us is, how good is crowdsourcing? How does it actually work? So over a 10-month window, I just realized that the description of the data is on the next slide, but I'll tell you. 10-month window, 296,000 sessions. So if you open the app and use it as a 15-minute window, that's a session in our minds, because people sometimes bounce back and forth between the app. And over 10,000 unique device identifiers. So that might be 10,000 devices, but it might not be, because if a person changed phones in the middle of the study, that it counted twice. So over 10,000 device identifiers. We ran this and looked at the performance of our prediction capability. So just the schedule itself, the historical version, and the real time. You can see an improvement in the ability to predict when the vehicle is going to come and driving down the variance in that prediction. Now, we also look at rush hour because most of our users are actually commuters, and so we actually have a much higher penetration of active users during rush hour, and that turns out to not make much of an effect. We get enough people kind of at the days to actually have a pretty good ability at making a prediction. The interesting question, though, is coverage, right? Because you're not implementing this on every single bus. It's just where your users are. This goes to the universal design point. You want to have as large a market base as possible, so you make it interesting and useful to as many people as possible. And what happens here is that, so keep in mind that of the people, of the trips in the transit agency that our app was used for during this period, we only covered about 0.5% of all of those trips. ABL would cover 100. Right? So we have a very small penetration. But we look at our users actually looking at the app, opening the app up, and what do they see? So remember, they're interacting with each other. So again, we're going to have bad coverage at 4 a.m., but we're going to have pretty good coverage during rush hour, and that's what happens. At rush hour, if you look at what people are trying to look at versus just the overall across the entire network, just what people are looking at in the app during rush hour, you see that we actually start getting above 20% in terms of value-added data with only 0.5% market penetration. So even though we had like 10,000 people, they're not all using it every day all the time. Over 10 months, they come and go. So this is actually rather heartening. But the downside, of course, is you're still not covering a lot of the trips where there's low utilization of the bus. If there's only 6 people on that particular trip, the odds of us covering it are very low. And in fact, if you look at the way that our system works, we tend to do very well in the major commute corridors of the city. That kind of map I showed you before, the heavy concentrations were near the universities and hospitals in one part of town, and the downtown core where all the lawyers and bankers go in the other part. And that's basically where we see most of our rides. Out on the outskirts, not so much. So one trick that you could do is say, well, how do we encourage people to contribute more? Because not everyone contributes. And so we ran an A/B study on this, where we assign people into one of three conditions, which is basically nothing, we don't do anything. Nagging, or request, where we pop up and ask you to contribute. And blocked, where you don't get data unless you contribute. Right? You get a little bit of data, and then after a while we cut you off until you start contributing. And then that kind of keeps going back and forth. And the threshold, we tried different threshold levels, but those didn't turn out to be important. And we did this again over 10 months. This is the cool thing about having a deployed system. You can do massive studies. And we had about 8,000 participants. Again, we're doing this based on device IDs. In the end, we went to control at the end. And the reason why is that, yes, you do get more data if you use this quid pro quo blocking strategy. Those people actually did contribute more, but they left the study and abandoned the app faster. And not only did they do that, they gave us horrible reviews in the app store. So years ago, Carrie and I got a review back from a funding agency saying, you know, why do we need to fund this kind of research? Don't those transit apps conduct research? And the answer is no, they don't. Nobody wants this review in their app store if they're a company. But in the end, we set it back to control because it turned out that it just wasn't worth the cost. We want to keep our users in the system because the more users we have, the more data we have for people with disabilities. Request had no impact. People are really good at clicking through nagging pop-ups. Okay, you know this, of course. You click through thousands of pop-ups. We have also done a study looking at people with disabilities. What is the actual impact on their daily lives? And we did this through a series of pre and post interviews, walkthroughs, a series of different things. And what we find is that it does improve accessibility in the transit system. There's a lot less pre-planning. We see opportunistic travel, which is interesting. So in Carrie's work, they found that people would walk to a neighboring bus stop to catch another bus. Or they would just not walk, they would not take a bus for a short trip, they'd walk instead. We're seeing evidence of this going to other stops as well in our data. We did this with people who are blind and people who use wheelchairs, as well as a control population. However, the exception to this is that wheelchair users, if it's a short trip, they don't even bother with the bus, because getting on and off the bus is such a pain that they'll just go by themselves. And if they use a power chair, there's really no fatigue, it's just exposure to the weather. So that might be, so this was an interesting result. We were not expecting more opportunistic travel among people with disabilities, but that in fact turned out, and the people who were blind were actually using the app to find and explore their neighborhood in ways that we weren't expecting. But in general, what we found was that yes, this works for people with disabilities, but this was a small study. We now want to do this at the data mining level, and we're kind of gearing up for that kind of study now. I mentioned Port Authority has ADL now, so as does New York, so we've started pulling their data into the system and merging it with the crowdsourced data, most specifically the fullness stuff, but to some degree, we're also, so for example, some of these systems, a particular bus may not have real-time data because the driver didn't punch in the right button, or that particular route doesn't have it yet, and we've actually, so we can actually start generating that data when the ADL isn't provided. So we're kind of in this direction now as well. And then the new version, which I was hoping the Android version would be soft released this week, but we're still having trouble with our server conversions. And this will be up, but this will be up shortly. We're shifting away from that one-directional report that we send into the website and the transit agency. Instead, we're sharing with, we're creating a peer-to-peer rider-to-rider communication, allowing riders to attach notes to individual trips or to stops. And we're giving them a variety of different ways of interacting, and we're keeping the photograph thing so people can attach pictures and things like that. Furthermore, we're adding in user profiles, specifically because I really want demographic data on people with disabilities, people to self-identify if they have a disability. And we also now have the ability to do things like push out a pop-up to filter groups of populations. So people who go to this bus stop, we can push a pop-up to them to do a probe down at that level, or we can do a probe to say everybody who commutes during the 9 o'clock rush hour or something like that. So I'm really interested in seeing where this goes, And in the meantime, we're doing a variety of different research efforts in terms of machine learning and other data mining structures. We're starting to collaborate with other people who have certain data sets that pair up nicely with ours to see what we can do about improving their analyses. And I want to kind of cover and end with an important topic, and this is kind of a thing where we come at Carnegie Mellon. We really like working in the real world. I come from the Robotics Institute. We're pushing robots out to Antarctica, volcanoes, all over the place. Same mentality here. We want to do real-world research with real-world data. And I know this is harder. It's a lot more painful. You have to deal with a lot more kind of hoops and gates to get through. I just realized I said gates, and one of those buildings says gates. Oops. But it has a huge impact on your research. You can run a 10-month study with thousands of users. Right? You can do an A/B study across an entire city. Furthermore, you can run into people on the street or at social events and say, "Oh, you're from the tiramisu team. I use that every day. Thank you." That's the kind of thing where as a researcher you're like, "Ah, you just made my month. This is great, right?" And so I encourage all of you to think about doing research in the real world, out there, not just on campus, not just with people who you know. Get out and actually do the deployment. So we have a large number of sponsors. This series of projects has been going on for a while now. Our core funding comes from NIDR, which is now called NIDLR, and they're in Health and Human Services. Traffic 21 gave